Today we'll discuss about a brief introduction about around generative AI. So we'll get to see how we can use large language models for summarization of a given document or something. So before I go forward with generative AI and large language models, let me give you a brief about why this Gen AI came into picture. So we know that there is a hierarchy in artificial intelligence and machine learning. Say, for example, if we have a bigger picture like this is AI, where we get to use a machine like computer to do some of the tasks where a human would take a lot of time. Okay, so we have AI. In AI, we have ML, machine learning. This is one of the part where we can have some models like decision trees, random forest, XGBoost, and so on. And under ML, we have deep learning. So this deep learning is more like where you have neural networks. Okay, and under the deep learning, then we have a better subset which is Gen AI. This is the point where we will have our large language models and all. So why we have generative AI is different because the world is changing pretty at a faster pace. When I say the world is changing, it means that we are collecting a lot of information and we are storing that information, and that information that we are storing, we can make use of that information to derive a lot of conclusions. Say for example, your buying patterns, it could be uh, the way, the taste of your movies or the taste of your music. So everything that you tend to listen or do something, all the activity is being tracked, and that activity is helping the models to predict a better song for you or a better movie for you, same like Netflix or a product in Amazon and so on. So in when you talk about machine learning, say for example, what is happening in machine learning is you're trying to predict a precise value. Say if we talk about classes like 0, 1, or 2, or a continuous variable. Say for example, we have price. I want to understand what should be the price for my raw material in the next month or 2 months down the line, given that uh, I'm sitting in month of January or February, or given that I'm going to get closer to holiday season like October and December, what should be the price of the product? Okay, so you're looking for a precise value. In both the cases, the value is very precise. You're not going to deviate very far from this class, or you're not going to deviate from very far from this particular price or stock value that you're trying to look at. This is where one should use machine learning. When the ask is about a particular value or a particular number, then we should stick to machine learning. Say the ask is not this, but I want the user to understand in complete human terminology. Say, for example, if I go into a bank teller and ask, I want to know the information about my account. So, and you expect not in numbers, right? You expect in some kind of a sentences, and that should have enough information in a conclusive way that the complete sentence makes some sense, so that the person hearing it can understand what should be the next step taken. So that is when we have a generative AI model which generates a complete paragraph and understands based on the context given, it understands what is the information that should be provided. Okay, more or less when we move from deep learning to generative AI, there is one common thing which will be used that is called as transformers. Okay, these are one of the models where we tend to give importance to one of the key information, like some precise words. Say for example, if I say what is the color of the sky, so the words like color, sky, and blue, they will have more importance as compared to the other words in that sentence. So when we give transformers such kind of a data, it generates which word is having how much of importance, and based on that, it tends to understand and remembers the context. Okay, that doesn't happen in the naive machine learning or the small language models like the LSTM or RNN or BERT. So they have their own limitations. That is the reason why we have Chat GPT and models like LLMs and all. So in today's demo, what we're going to do is we're going to see how we can use generative AI to get to summarize a given document. So, for example, if I upload one document to the model and ask, can you elaborate what the document is trying to speak? Say if the document is having like 15 or 20 pages, I want a crisp 5 or 6 sentences from the large language model. Before I go deep into that, I just want to show you how we can really do that, so that you get a hang of what I'm speaking about. So let's say, let me just minimize this part. Sorry for that. Now I'll just go to my Visual Studio. I'm not going to show you the code yet because it will be too much for you to grasp in a short video. But what I'll do is I'll try to run my code. I have my code written, and this is a fast API. So uh, one server would be running for my backend, and another server will be running for my front end. Say, for example, if I use this fast API for my backend service as a framework for running, communicating between the front end and the backend, I'm going to use this app, which you see inside. I'm going to tell you about the code also, after some time. But when I use this app, I'm going to invoke my fast API and make it available for the front end to communicate. Similarly, in my front end also, in the same folder, I have a front end. I'm going to start my front end server. Okay, so two things are running. One is my front end server, and the second is my back end server. Now, what I'm going to do is I'm going to go to my front end screen. This is a very simple, you know, a chat window where I will ask where I will provide some document to the large language model, and I'll ask some question to it. This is gonna take a little while, so just stay with me. I'll, I just downloaded this particular file from the internet, HDFC. I hope it is not, you know, privacy kind of a thing, but it's available for public, so I downloaded it. Now what I did is now I uploaded it. When I upload it, it does something in the backend. What it does is it's trying to read the document, and we are breaking the document into smaller chunks, which I'll tell you in when I go to the generative AI part. And each chunk we are trying to store in one kind of a database. Okay. Now that the model is like one, now that the file is uploaded, I can go and ask some question to the file. Now before I ask any question, I just want to show you what it is there in the file. So let me go to downloads, and this is the file which I opened, HDFC demo. And if you see, like, we have some heading like standard operating procedure, safe deposit locks. So what I'll do is I'll not use uh, standard operating procedure. I'll just look for safe deposit lockers, and I'll ask LLM to say what is the SOP for safe deposit lockers, and I'm gonna send it. Now, what the LLM would be doing is it is looking back in the code based on the question that I asked. It is going to There is one retrieval mechanism that is happening, and based on the retrieval, I get some chunks, and those chunks are sent to a large language model. From those chunks, the large language model is going to look into it and develop one crisp answer and give it back to you. So I did not elaborate what is SOP, but from the document, it understood that standard operating procedure is what SOP means, and it took away the answer that is available. So you can use a large language model to reduce the burden on the workers. Say, for example, if you are working for a bank and you have thousands of such procedures, how to handle a check deposit, how to cancel a check, how to open an account, how to close an account, how to make a transfer from one account to another account, all of these could be n number of SOPs. And imagine you sitting as a front desk and you have to go through these procedures. When somebody comes to you, it becomes very difficult. So we can make use of LLM and provide only that document which may probably have the answer, and LLM will do the final search and get back the result for us. Having said that, now you know what I'm talking about, where there is a interactive uh, communication happening between the user and the large language model, and there is some uh, process that is taking place in between. Okay, now we are going to discuss about what is that process that is happening. So it is more or less what it is happening is we are going to have a crisp English or a given language, without any grammatical error. You're going to have the proper communication back based on the question that you have asked. Okay, now let us go back. Now, there are two things which will happen in a generative AI model, or this is nothing called retrieval augment generation. It's called as a RAG. Now, there are two things. Now, first thing what I did was I used a document, okay, and I processed it. Now, what is the processing step? I'm going to explain you in a few minutes. And second step is there is a user query, okay. Now, let us talk about the first step. Let us say when you have document and this document is having a lot of pages. Okay, what we generally do is we send this document to some kind of a parser. Say if we are uploading a PDF document, I'm going to use something like an unstructured PDF parser from LangChain. I'm going to divide this document into individual pages. Okay, after dividing it into individual pages, I'm going to split it. Now what will happen in splitting is, say for example, if your document, this is one page of your document, it has like say 1,000 words. Now I don't want to pass all the 1,000 words into my chunk. Everything will have a defined set of input. Okay, say for example, if we have, in olden days we used to have a SMS. In SMS there was only like 140 characters. Okay, same like that, even every model to model it's have its own defined set of tokens that it can accept. So what we're going to do is like this 1,000 word document, we're going to divide it in, let us say, 500s. I'll take first 500 words as my chunk one. In the second 500, instead of taking the second 500 from here, I'm going to have an overlap. Let us say the overlap is like 100 words. Again, I'm going to take another 500. This is going to be my chunk 2. Okay, here I'll get my chunks. After getting chunk, what you're going to do is we are going to send it to an embedding model. For when we send the embedding model, this chunk till here it is in plain English. Whatever we are speaking, like whatever we have in a normal paragraph, it's in plain English. Once it comes back from the embedding model, you will have one list of numbers which we cannot understand. This list can be of defined length like 150, 300, based on what embedding model you choose and based on what embedding length that you want, it will generate. I'll talk about what are embeddings in a while, but just take it for granted that machine doesn't understand any words. It only understands ones and zeros. It cannot understand any alphabets. So even in the machine learning case, when we had categorical columns, we have to convert to one hot encoding, right? Same like that, we are going to use some embedding models, get some embeddings out of this chunk, and store it in a vector database. I store it in a vector database. I'm going to do it for all the chunks. How many of our chunks are coming? I'm going to store it. This is the first step. So given a case when you have customers data, what you're going to do is we are going to have one job which will identify if there is any new document, convert that document into chunks, convert that chunk into embedding, save that embedding into one database. That database can be anything like FAS or Postgres, or we have so many databases. Based on the use case, we can stick to it. In today's demo, what we are having is with FAS. I'll tell you about that. So this is part one. Now that we have all the embeddings, what we have to do is once the user query comes, we'll convert this user query to an embedding. We have embeddings here and we have embeddings in our storage. So we will do some kind of a cosine similarity or distance mechanism to identify what are the top 10 or 20 closed documents that is related to this question coming from the user. As simple as that. I'm going to use a cosine similarity to identify if two embeddings are near to each other or not. If they are near to each other, what is my distance? The closer the values to 1, the highly they are very highly related. The closer they are close to 0, it means they are not at all related. Okay, this is called as retrieval. This retrieval happens in this vector database. So given a question, what we're going to do is we are going to convert that question to embeddings, and between the embeddings of the user query and the storage that came from the documents, we're going to run some kind of cosine similarity and get the close number of documents. Let us say that we get like top k, like 10 documents. Now, until now, we did not invoke the large language model. We only have the embeddings. Now, what we are going to do is there is a third set now where you will have something like prompt, which will have context and the query, and that will go to the large language model. Okay. Then large language model will come with the answer. So to keep it short, I'm going to tell you in a diagrammatic way how this happens. Okay. Now, this is my document. These are my chunks. These are my embeddings. And it will be stored in a vector database. Now we have a user. This user is going to ask some query. This will go for embedding. Then we'll go for a cosine search. After that, parallelly we'll have prompt, and here we'll have LLM. This is like a black box. It will have access to the prompt, the vector database context, and the cosine similarity, like the query. And then after taking all these three inputs, it will revert back the answer to the user. This is what we are trying to do in the code. Okay. uh, when we have such communication happening, there might be a possibility wherein we don't get any value from this vector database. In such cases also, we have to handle it in the prompt. So now we'll go to the code and we'll understand what is actually happening in the backend. Okay. So I'll start off with, I'm not going to explain much about the front end because it has nothing to do much. It has a simple UI screen where we have a send button and a waiting spinner. Okay, and but in the back end, we have a fast API framework that is running. This is a fast API framework wherein there are two endpoints. First endpoint is an upload endpoint where we are going to uh, put all our documents and have them converted to one have them converted to an embedding and store it in a local database. Say, for example, if I have a document, I'm going to invoke this function save to local, where I'm parsing it by using uh, mu PDF loader. I'm using only PyMediaf loader because I know I'm going to accept only PDF files. But given a case that the upload can happen with a CSV or a Word file, in those cases, we need to have our own the respective parsers for those files. Okay, and if you notice, like we are trying to convert that document into embeddings by using for this case, we're using this embedding as OpenAI embeddings, the text embedding ADI 002, and After the embeddings are formed, then we are storing it in a vector database. Okay, this is the first part where I am going to upload the file, convert it to embeddings, and store the embeddings into files. When so I'm going to persist the data. I'm not going to lose it, so that if I want to restart, I should not lose the data. So I'm going to write it to my hard drive. This is the index.files which you see on the left side. This is the vector database. This is API 1. In the second API, what happens is we are going to have a chat window. So if you look at the process message, I have a prompt which I'm going to send. So I'm using LangChain here, and then I'm going to send all the a simple prompt, because the ask is very simple, that you have to summarize the document. If you find the answer, tell that you have the answer, and keep it short. Don't want to elaborate it very high level language and all. So we write that in prompt, and say for example, if you want some output in a defined way, this is the place where you have to explain the large language model how you want the output to be. So there are many features to it. There are many vanilla flavors. This is a very plain information about how you can do a simple chatbot thing with the large language model. So what I'm doing is I have a simple prompt where I'm asking the model to stick with 5 sentences and limit itself to the available data. If the data is not available, feel free to, it can tell that the data is not available. So for example, if I go to the window and ask, where does the sun rise? So it can do a check in internet, but I do not have the tool in the LLM, so it cannot get any value to it. But let's see what it says. So it says it seems there is no relevant context provided. So this comes because I have specified in the prompt saying that you're not supposed to deviate from the context that is available with this. If sun makes no sense in the context, you're not supposed to hallucinate, making up your own answers. That's what we're trying to tell to the model. Along with the prompt, we are also sending the question, and we are also sending the context. Now context is nothing but, when a user asks query, we are going to do a cosine search and get top 10 results or top 20 results of documents and feed those documents to the LLM model. So how you pass it is by using this pass-through mechanism in LangChain. Not in LangChain, there are many other features that are available, but I think LangChain is more easy to understand to start with. So I thought like we can get started with this. And from the model's perspective, I'm using GPT-4 Mini. We will have to use an OpenAPI key, which I stored in .env file, which I'm not going to show here. But anyways, you can store in a .env file and just put it under this key, OpenAPI key, and the model can easily understand from there that we have access and all. Of course, it comes with a price. It's not free that we can use as many API calls as we want. It is only for a demo purpose, so it doesn't cost me much. But this is how we can create one LLM model. So in this case, I'm using GPT-4o Mini, and then I'm invoking the model with the respective context and the question. When I talk about context, this is where we have to be very careful. Like when I go to this custom retriever, let me go back to, yeah, custom retriever. So what it does is it loads my local Firestore as a local DB. I'm loading it. I'm storing it as vector store. And in vector store, I'm doing a similarity search for the given query. So when you see at my backend, see this is the query that is there. What is the SOP for safe deposit lockers? And when I ran this query, it took a couple of documents along with its cosine score. You can see that cosine score for few documents it is 0.84 and few other documents it is 0.73. I took only 10 documents. So it took like all of those 10 chunks and explained the answer based on those 10 chunks. Probably you will have many other chunks, but it would not be necessary for us for this particular query. Okay. So this query search is happening in this particular area where, sorry, in this particular custom retriever where we are doing a cosine search and we are getting the top 10 documents. Okay. Uh, if you want to improve the model accuracy, for example, say uh, the model is not performing very well for with the because of the limited data or something, you can perform a top P top K kind of a fine tuning where you can ask the model, say for example, you generate for example, you fetch like top six answers from the context that is available, and you ask the LLM to make another four uh, out of those six available answers. So it can create more sentences out of it, and then it can look into those answers and get back with the answer. Okay, so there are many other ways of handling the improving the LLM's performance. We re, we usually don't retrain the LLM. We only improve the accuracy by doing some fine one shot examples or few shot examples kind of a thing. And other things are just for the aesthetics and all. So we have prompt, as I said, and then we have cosine search, and then we have the place where we are trying to embed the documents and store it in the vector database. So if you look at a generative AI, it is pretty easy as compared to machine learning or deep learning, because that machine learning and deep learning is a very huge chapter to understand, a lot of mathematics to go through. But generative AI is like pretty easy, like any non-technical person can also understand. That is where, like, we hear most things around prompt engineering and all. So we can make use of generative AI and reduce a lot of front desk, uh, or we can increase the throughput of the front desk operations. Let us talk about embeddings now. Say, for example, I take a simple word like king and I write a big paragraph around it. And this paragraph speaks about everything about king, how the ruler is formed, what are the powers that the ruler has, what punishment does he give when somebody makes a mistake, whether he is too strict to the people or not. So, for example, I'm going to describe everything. When we have some sentences like this, we tend to give some weightage to all of these important words. Okay, so when I talk about ruler, I give some value. When I talk about powers, I give some value. When I give talk about punishment, I give some value. Same is the word for strict. So every word that is emphasizing about the king, we are going to give one value. The same happens with the movies also. Whether the movie is about talking about romance, whether the movie is talking about comedy, whether the movie is talking about action or sci-fi, the genre part, we can divide the movie into multiple segments and give a number to it based on what the movie is trying to tell and how the movie is being rated by a given user. And this happens for n number of users, n number of ways. Okay, so what I'm trying to tell is the way we come up with these values for a given person or a word, similarly, embedding is also formed in a way. But we cannot tell if embedding is talking about this particular word or not, or about this particular word or not. It identifies some features. Okay, let us say if I want to generate an embedding length of 150, it identifies length of this 150 different different attributes of that particular word and gives one number to it. So this is how we can convert. Say, for example, if I have a simple one hot vector, I have north, east, west, and south. When we are converting this one hot vector, when we convert this column as a one hot vector, what we get is like for north we get 1000, and for east maybe we get like 10100, and for west it will be like this, and for south it will be like this. Sorry, this will be like this. So for north, this is the vector. We can imagine this is the vector. For east, this would be the vector. So the number which changes changes the attribute about this particular word or name. Similar way, even for all the English alphabets, based on the context that it was placed in, based on the paragraph that we have written, we tend to generate some numbers to it. And this happens because of trained thing. Like, when we have a target about king and all these attributes are trying to predict what this king is like, each attribute will have its own weight. This weights is nothing called as an embedding. Okay. Embedding can be anything like glow to vec, TF-IDF, all of them. But what we usually do is we just form a list of numbers, but we don't know. It's kind of a black box to understand. If we take only one number, we cannot tell what that particular number is trying to speak about. We cannot tell that. So if we say the embedding length of 150, the 150 embedding length for a ruler and power would be different. Machine can identify that they are different, but probably machine doesn't know what ruler is, but it can understand if I speak about ruler, what are the attributes a ruler would have, or what are the attributes a power would have, or what are the attributes punishment would have. It can relate all of that and it can store it in form of embeddings. And these embeddings would be used by the large language model to understand if two chunks. Now I'm going to prepare an embedding for the complete chunk. I'm going to take one paragraph. Embedding is for the whole chunk, not just for one word or one sentence. It's for the whole chunk. And then when a query is asked, it can the rack can do a quick cosine search and bring up all the documents which are very closer to the user's query. And these documents, which are very close, form as a context and send to the LLM. LLM then it can understand all those context based on the query asked. It can do a quick search again and come up back with a crisp answer. That is it.